Okay, pause and copy all of this. Pause and copy, pause and copy. Okay. So, in the real, okay, this symbol here. This symbol means there exists an n by n matrix C such that both AC and CA are I. If you wanted, you could put an N here as the subscript on I. Should be an N. Oh no. No, I'm just going to leave it I N. Okay, so the inverse of A. Okay, in the 2 by 2 case, we have a formula. Doesn't always work, okay? But when it works perfectly. Proof. Pause and copy. I want you to try this. So you are calculating this product and this product to verify that this is true and this is true. So pause, try that. Pause, try, pause, try. Okay. Example, just using this formula. Okay, A inverse is 1 over AD minus BC all over D minus B minus C A. So what happens? The 2 and the 5 switch positions, and these guys change sign. So we'll start there. Kind of 5, 2, then minus 3, minus 3. And then you get 1 over AD minus BC, which is 10 minus 9. So in this case, you have a nice fraction here. That won't always be the case. So how about an exercise? Let's try something. A is equal to something not so nice. Oh, who cares? 7 minus 2 minus 4 and 5. All right. A inverse equals what? So pause, try that. Pause, try, pause, try, pause, try. So A inverse is 1 over AD minus BC, which is minus 14 plus 20. The negative 2 and the 7 switch, and the numbers on the other diagonal change sign. So what is this? 1 over 6 minus 2, 7, 4, minus 5. And you can leave it like that, or you can multiply in. It kind of depends what you're doing with this matrix. Yeah, let me just double check them. Okie dokie. Okie dokie. Okie dokie. Okay, what's next? Number 6. Okay, let A be, n by n, comma, invertible, also invertible. Okay, so invertible means that A inverse exists. You cannot expect A inverse to always exist. Maybe we'll talk about some cases where it doesn't exist shortly. But for now, let's just do some stuff. Okay, so we can figure out these three things. If you invert a matrix twice, what do you get? Well, you come back to where you started. If you invert a product, in fact, you reverse the order. And the transpose and the inverse can switch places. Why don't I prove one of these? Proof of B. Proof of B. So I'll say let C equal this candidate. What do I need to do with this C? Well, I need to show, NTS, need to show CA is equal to I and AC is equal to I. So here I'm just telling myself what I need to do to establish this claim. So I will calculate CA. What is CA? CA is, oh no, I screwed up royally, haven't I? I wretchedly screwed up. Okay, I need to totally rewrite what I've circled here. I want to prove that this dude is the inverse of this matrix AB. Okay, so I need to fix this. Let's go with purple A, B. And down here I have to go A, B. Okay, so I rewrite this thing. I have to prove that this matrix here is the inverse of AB. That's what the claim is here. Okay, sorry about that. CAB is, okay, so that's B inverse, A inverse, AB. So what do you get? B inverse, well, A inverse times A, that's just I, right? That's just I. So I, B. Now, in the land of matrices, I behaves much like the number 1. Okay, so when I go 1 times 6, I just get 6. And when I take I times a matrix, whatever B, well, I'm just going to get B. And also B times I, it's also just B. So I get B inverse times B. This thought bubble here, I think it's a property in 2.1. It's in your book. It's in your book somewhere. Okay, so B inverse B, that is just I. So I accomplished this part. And then the other way around, A, B, C is going to be AB times B inverse A inverse, which is A, A inverse, which is just A times A inverse. Okay, so again, I in the land of matrices behaves much like the number 1 when it comes to multiplication. Et voila. And that is what I get.